Hey everyone, it's Zsolt here. I'm in Eastern Slovenia on holiday and I'm reading Visual Thinking for Information Design by Colin Ware. I'm not yet done with the book, but the book is so rich in useful information that I thought I would share with you what I've learned from the book so far, and maybe I'll cover the rest in an upcoming video. I stumbled upon this book as I was doing research for my previous video. And if you've not seen this, I recommend watching it. It's a scientific discussion about the value of visuals and how they compare to words. And of course, the word reading this book is a bit of an understatement. I'm really studying this book. I created or started to create this concept map. And of course, I have my book chapter summaries. Each mind map is a summary of a different chapter, and there are many more chapters to go. You can see that I've captured a lot of ideas as I was reading. Many of this is new to me, and it is really super useful and helpful material. The promise Colin makes is that by understanding this, it will help you decide which colors to use, how to organize space, when to use images or words. And this is going to make your diagrams, your slides, your whatever visual delivery you do better. You'll be better equipped to communicate the information you want to share with your audience, or rather what your audience needs with them. Now, the book is so good that I'm actually thinking that maybe for cohort 11 of the visual thinking workshop, this is going to be the book that we read together. Quick reminder, cohort 10 is starting in a week's time. You still have time to sign off if you want to. Now, the starting idea or the way Colin starts his book is this idea about the dance between internal and external information. He defines so seeing is not a passive activity. It's not about me looking at something and that's it. It's a dance between internal and external information. He talks about a bottom-up information channel, which involves seeing features, patterns, identifying objects, etc. And there's a top-down process, which is based on your attention, based on your objective. You're going to plan the next eye movements, and you're going to direct your seeing, your pattern recognition based on the question, the visual query you have in mind. And so these two together form this dance of visual thinking, seeing, essentially. So Colin covers a couple of basic concepts. The first one is predictive cognition. And predictive cognition is about the mental models you build up to understand certain situations. Colin states that memories are not there to reminisce over the past. That's sort of a side effect. Memories are predictive models guiding future action. So for example, when you walk into a supermarket, your brain will pull from its memory all the history supermarket experiences and will help you orient yourself. You'll see the aisles quickly. You'll be able to find your groceries or whatever else you need quickly because you'll have a mental model of the space that you entered. And similarly, if you pick up a map or if you look at a slide, you will always immediately bring with yourself your mental model of how those certain visual situations work. And of course, if, for example, you enter the supermarket and things are organized very differently, you'll be frustrated because your mental model doesn't fit with your experiences. Now, why do you need to know this? It's because when you design a visualization, you need to understand what mental models are available or are in the head of your audience, and you need to tune your visualization to them. you need to make sure that there are certain reference points that your audience can find in the material so they can orient themselves and find what they need quickly. So here on the right hand side, you can see that image that your audience comes with different questions, visual queries, and the visual that you provide should provide some reference point that helps them orient themselves and then find the information. And the task of the visual designer is to create these visual experiences that feel seamless, where it's easy to find information. And we'll talk about this in just a couple of minutes, but I thought here it's an interesting point to mention this example in the book. So first, your task is to find the P's, and of course you can very quickly find the two P's. The second task is to find the Q's, and it will take quite some time to find the Q's. And think about, why is it more difficult to find the Q's and why is it easy to find the P's? Because you need to understand the mechanism behind this so that you can design the space for your audience. And in this process, Colin talks about this several layers of information processing in our brain, the retinal image, and then the feature processing, constructing patterns, identifying objects, binding objects to ideas in our mind, and so on. And some of these elements of this process, especially the ones at the top, for example, feature processing, are much more automatic and uniform than the later ones. So if you understand what's happening at the feature processing level, what is happening at the pattern construction level, you can target your visual material to the right place. Now, moving on, the other concept that Colin mentions is about active vision. And he starts with this idea that graphic designs are cognitive tools. They enhance and extend our brains. And this actually reminded me of this idea of the detachment gain that I read in The Extended Mind by Annie Murphy Paul. The idea of the detachment gain is, if you take your ideas and put them on a whiteboard, you can take a step back and observe them in a spatial setup. And this distance between your ideas on the whiteboard and yourself creates an opportunity to reflect, and that's the detachment gain. Now, when you look at a visual thinking is always about pattern finding. It uses your brain's pattern finding abilities. And very often, to see a pattern is to understand the solution to a problem. So think of the situation of a map. The moment you can see your origin and destination and you can trace the line, you know which tube or subway you need to take to get from one station to the other. So in this case, you can understand how the pattern finding is your solution actually. And the hallmark of a good visual thinking tool is that it's easier to use the tool than to do everything in memory. Now, moving on from here, a very important idea, and I think a central idea in the book, is that at any moment of time, we perceive only a very small portion of our surroundings. It's only an illusion that we see the entire world. And this has to do with how our eyes work. And Colin makes this comparison between a digital camera and our eye. And there are many similarities. So both have receptors and both will then send the information to some sort of a processing unit, etc. But there are two very important differences. Difference number one is the pixel distribution. In a digital camera, you have pixels uniformly distributed on the picture, so you will have the same density of pixels in the top left as in the center or the bottom right, not in your eye. So in the fovea, in the central part of your eye, you'll have about 95% of your receptors. So that's 5% of the eye has 95% of the receptors. And as you go out to the edges, you will have less and less receptors. So that's why your peripheral vision is blurred. So that's one difference. The other difference is this difference about what I call edge computing, that actually we don't send the entire information back to our brain, but it goes through these several layers of processing. And by the time our mind works with the ideas, it is sort of detached from the original pixels. And in this process, some of the steps are sort of built in. They're, I wouldn't say hard-coded, because feature processing is something you learn as an infant, but there are elements of this process that you cannot actually control. And so moving on from here, this takes us to this concept that the world is its own memory. So because our attentional capacity is so limited, we forget irrelevant information very quickly, and it's replaced by information that we currently need. So it's sort of like this, that this is a map of the world, but you will only focus on the small part that you need from that information. So this is your entire environment, and you're only going to focus on the pieces of information that you immediately need. And often you don't even realize this, because you can so rapidly and unconsciously access the additional information with additional glances that you don't even notice it. But in reality, this is how you see. You will see only that point. The rest you will sort of imagine. It's only an illusion that you have. The rest is there. So from this perspective, seeing is all about attention. And attention is driven by the visual queries, and of course driven by the mental models that you're using to guide your attention. So if we now go back to this example about the peas and try to conclude this video with some practical examples of how you can apply what we've discussed so far. So why do P's stand out and why do Q's not stand out? So to understand this, you need to, again, understand how the feature processing, which is at level 1 and level 2 here on this diagram of the brain, happens earlier in the processing as deeper cortical layers. And some of the feature processing is really automatic. You don't really have control over them. And this is just another way how this hierarchy of understanding works, that on the left you see your eye, and as you move to the right, you have more and more control, attentional control over what's happening. At the features level, features are sort of automatic and irresistible. So the experiments that look at why P and Q, from the previous example, one stands out, the other doesn't, always include a shape and distractors. And indeed, in this case, you can see that there are two types of shapes that stand out. Of course, there's the big bubble that stands out, but also the red lines will stand out, and you'll see why in a second. But what stands out, this pop-out effect happens because of what are called visual distances, which is the contrast between an object and its surrounding. And so the book includes these examples of various features that our brain distinguishes. So you can, I'm not going to walk through on all of these. Some of these are stronger and some of these are less strong. So for example, convex and concave will stand out less than, for example, a gray value difference or a shape difference. And then you should also think about why the 3 green squares do not stand out here. So again, following the previous logic, why did the Q stand out and why did the P stand out and the Q didn't? So why doesn't the green box stand out on this picture? And to understand all of this, you need to understand about these feature space diagrams. What you can see on this diagram is on the 2 axes, one the vertical axis is the color, the horizontal axis is the size. And so when you take all the objects in a field of vision and you categorize them based on this, then you will see some clusters, or maybe you will not see any clusters, but bubbles all over the place. If you see a cluster and if you see an object that's separate from that cluster from the perspective of these features, then that item will stand out. And of course, you can do this in multiple dimensions. So on the previous chart, you could see that there are many different features. So you can put these all together and create diagrams where different elements stand out for different reasons. So here's an example where there are multiple dimensions that stand out nicely. So you can see one is a color dimension, the other is a shape dimension, and compared to the green and red circles and squares, this one actually stands out pretty nicely because the distances are bigger because these various shapes are in clusters. And then for the features of the shapes are in clusters. And then here's another example where you can even combine multiple items to make an even stronger pop. And then finally, to conclude the conversation, there's another approach that Colin explains, and this is about using multi-scale structures to design for search. And in this case, you will first look for the structural part where the information you need is, and then you'll dive in with a next glance or a third glance to find the actual information you want. So for example, think of a diagram where you know that the legend is on the top right-hand side, and then immediately, or the title is the top left. So when you look at the chart, you know that if I need to find the legend, I'm going to find it. It's going to have maybe a box around it. And then with the next glance, you can look at the legend itself and learn about the information that's there. So that's in a nutshell. There's lots more. I didn't talk about the bottom mind map, but I think this was already long enough as a conversation. I hope you found this summary helpful. And yeah, if you're interested in learning about this and how to apply it to your personal knowledge management, to your own workflows, I cover many similar topics in the Visual Thinking Workshop. Cohort 10 starts in a week time. But equally, if you're interested in this, I recommend picking up this book. This is a dense and difficult book if you're not familiar with the subject as I am. So you're going to take lots of notes, but it's also a super interesting and very hands-on book. There's some theoretical discussion about how your brain works and how your mental systems machinery works, but it's not too detailed, but it's also not too superficial, that it gives you some grounding to then understand the different tools and approaches that Colin explains for how to organize information and present information. So thank you for taking the time to watch the entire video, and I'd love to hear what you think about this. If you have found other books that are similarly interesting, any feedback in the comments below, please share. Thank you.